Vespa 150 Tap. The Vespa 150 Tap is the only motor scooter ever designed to destroy a tank. Built by Acma in France between 1956 and 1959, it weighed 254 pounds wet, the mass of a household refrigerator, and carried an American M23-inch recoilless rifle running longitudinally through its frame, the barrel protruding through a cutout in the front leg shield. Approximately 600 were built. The recoilless rifle worked by venting propellant gases rearward through a perforated breech, canceling the forward thrust that would otherwise send the scooter cartwheeling backward. The shell weighed up to 22.7 pounds, left the barrel at 984 feet per second, and penetrated nearly 4 inches of armor plate, enough to defeat a contemporary medium tank. Each scooter carried 6 rounds in side racks and was airdropped in pairs on reinforced pallets with a 2-man crew. The weapon was normally dismounted and fired from a Browning M1917 tripod, also carried on the scooter, but in emergencies it could be fired directly from the saddle. The Tap saw service in the Algerian War, where its narrow profile let it operate on mountain trails that blocked heavier vehicles. It gave French paratroopers organic anti-armor firepower without towed artillery, the lightest self-propelled anti-tank weapon ever fielded. Tsar Tank. The Tsar Tank is a 66-ton armored tricycle with 30-foot spoked front wheels, funded by Tsar Nicholas II in 1914, after a wind-up wooden model climbed over a stack of books on his desk. Designed by Russian engineer Nikolai Lebedenko, it was built in secrecy outside Moscow and rolled out for trials in August 1915. It remains the tallest armored combat vehicle ever constructed, standing 30 feet high, the height of a 3-story building. The spoked front wheels were inspired by Central Asian Araba transport carts. A 5-foot rear roller on a trailing boom handled steering. Two 240-horsepower Maybach aircraft engines, salvaged from a downed German Zeppelin, drove the wheels through a friction system, each engine spinning, a standard car wheel pressed by railway carriage, springs against the inner wooden rim of the giant front wheel. The machine failed on its first test. The front wheels crushed trees, but the small rear roller concentrated the vehicle's weight onto a tiny footprint and sank into the soft forest mud. The Maybach engines lacked the torque to free it. The prototype was abandoned in the clearing under guard, rusted in place for 8 years, and was scrapped in 1923. It proved that a mechanism that works flawlessly as a desktop toy can fail completely when scaled to combat mass. Goliath Tracked Mine. The Goliath is a knee-high tracked robot packed with explosives and steered by a joystick on the end of a cable, the first mass-produced robotic weapon to see active combat. Built by Borgward and Zundap between 1942 and 1945, the German military produced 7,564 units. Each measured roughly 5 feet long, weighed 815 to 948 pounds, and carried 132 to 220 pounds of high explosive behind 1/5 to 2/5 of an inch of mild steel armor. Commands traveled through a triple-strand telephone cable that unwound from an internal drum as the vehicle advanced, with a maximum range of just under a mile on the electric model and 7.5 miles on the gas versions. The explosive payload was sufficient to destroy a concrete pillbox or disable a tank. It was deployed during the Allied landings in Normandy, on the Eastern Front, and during the Warsaw Uprising. The weapon was tactically disappointing. The thin armor offered no defense against anti-tank rifles, and concentrated machine gun fire could detonate the internal charge prematurely. Allied soldiers quickly identified the operational weakness: the trailing command cable. A soldier with wire cutters could sever it, leaving the vehicle inert and safe to capture. The Goliath is the direct ancestor of every unmanned ground vehicle fielded since. PZL M15 Belphegor. The PZL M15 Belphegor is a jet-powered biplane crop duster, the only one ever built and the heaviest biplane ever produced. Manufactured by WSK PZL Milek in Poland between 1976 and 1981, under a Soviet contract intended to replace the Antonov, 175 were completed. Maximum takeoff weight was 12,450 pounds, double the AN. It was meant to succeed. The power plant was an Ivchenko Progress AI 25 turbofan, the same engine used in the Yak 40 airliner, mounted high above the central cabin beneath the upper wing to protect it from ingesting stones and chemicals during low-level runs. 2 large vertical chemical tanks connected the upper and lower wings, giving the aircraft the silhouette of a flying cathedral. Payload capacity was 766 gallons of liquid, or 4,850 pounds of dry chemical. The nickname Belphegor, after the noisy demon of hell, was assigned at the 1976 Paris Air Show by observers struck by the screaming exhaust note. Top speed was 124 miles per hour. The aircraft also had a secondary military role for Soviet chemical troops, intended for large-scale aerosol dispersal or decontamination of radioactive fallout. It consumed 3 times the fuel of a piston-engined alternative, and its hot exhaust occasionally incinerated the chemicals before they reached the crop. Production ended in 1981. Surviving airframes were stripped of their engines to keep Yak-40 airliners flying. Kugelpanzer. The Kugelpanzer is an armored steel ball containing 1 German soldier of unknown purpose, with almost no surviving documentation explaining why it was built. One example exists, held at the Kubinka Tank Museum in Russia. It weighs just under 2 tons, measures 5 feet tall, and is armored with 1/5 of an inch of mild steel, the smallest armored fighting vehicle of the Second World War. The structure consists of a stationary central cockpit flanked by 2 large hemispherical rotating wheels that provided propulsion, with a small trailing wheel on a rear boom for steering. Power came from a single-cylinder, 2-stroke motorcycle engine, producing 24 to 30 horsepower and an estimated road speed of 31 miles per hour. The interior offered space for 1 operator in a hunched position, with a horizontal viewing slit cut into the curved front nose. It is presumed to have been manufactured by Krupp as a mobile observation post for an artillery spotter. No blueprints, design logs, or operational records survive. The Soviet capture in 1945 has 2 competing accounts, one placing it at Kummersdorf near Berlin, the other in Manchuria with the Japanese Kwantung Army. The Russian museum has never permitted a detailed teardown, leaving the interior mechanism classified and the vehicle's true purpose unrecoverable. Antonov A-40. The Antonov A-40 is a Soviet light tank with wooden biplane wings bolted to it, the only tank ever to fly. Designed by Oleg Antonov and tested on September 2, 1942, it combined the hull of a T-60 light tank with a glider assembly spanning 59 feet and a twin-tail boom structure. Total weight was 17,200 pounds. The Soviet Air Force wanted a system to deliver light armor directly to partisan units operating behind German lines, places no conventional cargo aircraft could land. Control was routed through the tank itself. Cables ran from the driver's compartment through external pulleys to the ailerons and flaps. Pitch was managed by elevating the main gun, roll by rotating the turret. The landing gear was the tank's own tracks, which the driver had to start spinning at touchdown speed before contact with the ground. To make the airframe light enough to fly, engineers stripped the T-60 of its armament, ammunition, and most of its fuel. The maiden flight was towed by a TB-3 bomber. The aerodynamic drag of the tank limited the tow speed to 81 miles per hour and altitude to 130 feet. The bomber's engines began to overheat almost immediately, and the tow line was released early. Test pilot Sergei Anokin glided the tank to a clean landing in a field, started the engine, dismounted the wings, and drove the vehicle back to base. No further flights were attempted. The drag of a steel combat vehicle was beyond the towing capacity of any Soviet bomber. Hiller VZ-1 Pawnee. The Hiller VZ-1 Pawnee is a flying disc for 1 soldier, steered entirely by leaning. Developed under a U.S. Office of Naval Research contract beginning in 1953, it first flew on April 2, 1955. The original model weighed 370 pounds empty and measured 8.3 feet across. The pilot stood on a small platform mounted above a fiberglass duct containing 2 contra-rotating coaxial aluminum rotors powered by twin Nelson, 2-stroke engines, producing 80 horsepower combined. 40% of the lift came not from rotor thrust, but from low-pressure air moving across the curved leading edge of the duct rim, the same principle that generates lift on an aircraft wing. Steering used no flight controls. The pilot shifted body weight in the desired direction and the platform tilted to follow, the same kinesthetic principle as a skateboard. Top speed was 16 miles per hour. The system worked on the lightweight Navy model. When the U.S. Army ordered a larger version with a 3rd engine, the added mass broke the kinesthetic control entirely, forcing engineers to install conventional helicopter cyclic controls and defeating the original concept. A second failure appeared at altitude. The platform was stable inside ground effect within 33 feet of the surface. Above that, the air cushion collapsed and the platform entered a violent oscillation called hubcapping, which threatened to throw the pilot directly into the rotors. The program never advanced beyond prototype trials. Progvev-T. The Progvev-T is a Soviet tank with a MiG-15 fighter jet engine bolted on top, designed to detonate landmines by blasting the ground with superheated exhaust. Developed in the 1970s, it consists of a T-54 or T-55 hull, with the gun turret removed and replaced by an armored housing containing a Klimov VK-1 turbojet. Total weight is 41 tons. A large kerosene tank on the rear hull feeds the jet. The engine points forward and slightly downward, blasting a high-velocity exhaust plume across the ground, ahead of the tank, peeling back topsoil and detonating pressure and thermally activated landmines through thermal and kinetic shock. The cleared corridor is 33 to 39 feet wide, enough for an entire convoy column rather than the single-track width cleared by mechanical flails. Operational speed is 0.6 to 1.9 miles per hour, with enough fuel for 3.7 miles of cleared road before refueling. The reliability claim against mines is 99%, but the operational drawbacks ended the project. The exhaust raises blinding clouds of sand, dust, and superheated debris that completely obscure the crew's vision, leaving the driver unable to see whether the tank is tracking down the cleared corridor or drifting sideways onto uncleared mines. The noise can be heard from miles away. The vehicle never entered serial production. Bartini-Beriev VVA-14. The Bartini-Beriev VVA-14 is a Soviet submarine hunter designed to take off vertically from open ocean, then skim the wave tops at 472 miles per hour on a cushion of trapped air. Designed by Robert Bartini and the Beriev Design Bureau, it first flew on September 4, 1972. The wingspan is 98 feet, maximum takeoff weight 114,640 pounds. The mission was hunting U.S. Navy Polaris ballistic missile submarines in the Arctic and Pacific. A broad central lifting body forms the main wing and houses the crew, flanked by two longitudinal side sections originally fitted with inflatable rubber flotation pontoons. Cruise propulsion came from two Soloviev D-30M turbofans. Vertical takeoff was meant to be powered by 12 Kolosov lift engines mounted in a battery within the central fuselage. The mission profile included low-altitude wing and ground effect cruise just feet above the wave tops, exploiting the high-pressure air cushion between the wings and the sea surface for extended endurance. The 12 vertical lift engines were never delivered. The Rybinsk Engine Bureau failed to complete them, leaving the cavities in the central fuselage permanently empty. The inflatable pontoons leaked and vibrated violently during water taxi, forcing engineers to replace them with rigid steel units that added weight and destroyed the aerodynamic balance. After 107 test flights and the death of Robert Bartini in 1974, the program was canceled. The single surviving hull sits dismantled and rusting outdoors at the Central Air Force Museum in Menino, the empty engine cavities still visible.